Let us look at the topic constant. So const is a qualifier in C++ which is used at various places. So I'll show you all the places wherever constant is used and what is its role. So let us start. The first thing is inside the main function, I have a main function. Now I'm taking a variable x having value 10. You know well that when you declare a variable, it will have some memory. Let us say the address of that memory is 202.1 and the value 10 is stored there. We are familiar with this variable. Then, can I say x plus plus here and then I will say cout x. So what happens? This becomes 11 and then 11 will be printed here. This is a simple thing. Now constant. If I write const in front of this one, then this is a constant identifier. It's not a variable. Constant identifier. Variable also identifier, but it's a constant, so it's an identifier, but not a variable. And constants, when you said, you cannot modify this one. So the value 10 cannot be modified at all, right? Value 10 cannot be modified. If you write this, you will get an error. So constant identifiers cannot be modified throughout the program. So if you have some value, you want to hold it as it is, then you can declare it as constant. So it is just like we also use hash define, right? Hash define x 10. So what is the difference between this? That is preprocessor directive and it is executed and it is performed before the compilation process starts. But here, this is an identifier which will consume memory for the integer. We were assuming integer takes 2 bytes, right, in our discussion. So take 2 bytes, let us say, and that memory will have the value and it cannot be modified. So that is just a symbolic constant and this is a constant identifier. That will not consume memory, this will consume memory. That is not part of a language, outside compiler, pre-compiler, and this is a part of language, this is part of compiler. So if you have any constants that are globally used in the project, then you can go for this one, and inside the function, inside a class, if you have any constants, then you can go for this type. That are globally useful, that can be applicable for entire project if you want, right? So this is one usage. Now next, we will look at second usage of constant, that is constant pointers. Now let us look at this. This is a known thing for us. I have a variable and a pointer ptr. So this is a ptr pointer. It's pointing on this variable x. So this is pointing here. So it's having the address 200. Then next line, I said plus plus star ptr. So star ptr, go to this location and plus plus, this becomes 11. So 10 becomes 11. So this will modify and cout x, it will print 11. X value is 11. This is a simple code. Now let us understand constant. Pointer to a constant. Pointer to a constant. So pointer to a constant integer. If I say this, then this pointer can point on x and it can access x, read x, but it cannot modify x. So this is not allowed. So using this pointer, it cannot modify the data. This data is logged for this pointer, right? So this pointer cannot modify that data. Data is locked. So, but can I say star ptr here? Yes, star ptr if you say, then the value 10 will be displayed. So it can read this value, but it cannot modify it. So this increment cannot be done. So that's it. Pointer to a integer constant. So you read it from right side. Pointer to a integer constant. So a pointer cannot modify the data because it will treat the data as a constant. This can be written in other way also. I can write it like this also. Int and const, then star ptr. So even it can be written like this. Now the next thing I will show you. Suppose I have one more variable y and it's having value 20. So this is also there, which is having value 20. Let us say its address is 300 and 301. Then can I make this pointer ptr point on y? Yes. So it will not be pointing here now. It will be pointing here and it is having value 300. So I am making a pointer point on something else. So You can make the pointer point on some other data, but you cannot modify that. Still that y, can I modify it? Star PTR means go to that data and plus plus, modify it. You cannot modify. So a pointer to an integer constant or pointer to constant type cannot modify the data, but it can point on any data, but that data it cannot modify. So it's pointing on y also. So two usages of constant we have seen. Now let us see the third usage of constant. Just watch here. Instead of star here, I will write star here. Now read it. PTR is constant. It is a pointer to an integer. So who is constant here? Data is not constant. Integer is not constant. PTR is constant. So what does it mean? This PTR you cannot modify. Once it is pointing on X, this is pointing on X. After that, you cannot change this to point on any other variable. You cannot move the pointer to some other variable. So who is locked now? Not the data. Pointer is locked. Pointer is locked. The address in that pointer cannot be changed. This is an error. This is an error. So you cannot make it point on Y. So this is a constant pointer of type integer. Right? Pointer itself is constant. That time data was constant, but now pointer is constant. Pointer cannot be modified to point on any other data member. Right? So this is the third thing. Now let us see fourth usage of const. Fourth usage of const. I will write const here also. So this is a constant pointer to integer constant. Constant pointer to integer constant. Now this pointer cannot be modified to any other data member, and even it cannot modify this data member. So it is locked on both, that is data as well as pointer. So here I cannot do this one, so even I cannot do this. I cannot modify. Suppose it is leave y now, leave y. If it is pointing on X, I cannot modify this, and even I cannot modify it on Y. Let me show you here. See, PTR is pointing here, so I cannot say plus plus star PTR means go to that data and modify it. I cannot say, or even I cannot say PTR assign ampersand Y. I cannot make it point on any other value. So this is a constant pointer to integer constant. So this was the fourth way of using constant. So there are three types of constant pointers now. That is, pointer can be constant, pointer cannot be modified. Data can be constant, so the pointer cannot modify the data, or both can be constant. So I have used constant 2 times here. Now next, let us look at constant keyword in functions. So let me write the example and show you. I have a program here. This is a class demo having data members x and y and a display function. This is incrementing the value of x and displaying x and y. If you check here, display is incrementing the value from 10 to 11, then it is displaying 11 and y is 20, 11 and 20. Now here in the main function I have created an object of demo d that I am calling display. So what will be displayed here? So this will display x, that is 11 because it has changed here, and 20. So you will get the answer as 11 and 20. So this is how it is working. Now let us come to the topic. Constant keyword. Listen, this function is accessing this members, right? Accessing, yes, reading. It's also updating the data member, modifying the data member. If you don't want the member function of a class to modify the data member, just to read the values, don't modify the values, then you can write down const just after the function name inside the prototype of a function. After the function name, write const. Then compiler will restrict this function from modifying the data members of a class, so this will not be allowed. So if you are sure that this function is not going to modify any data member, just declare const there. So if by mistake, if you are modifying anything inside the function, compiler will come for your help and say that you said you are not going to modify anything, but by mistake you have modified something here. So this is the 5th usage of const. Now one more last method of using const I will show you. So I'll remove this and give an example. Then from that I'll explain. Now one more method of using const. So for that I have taken an example. Let me explain the example. I have a main function a with 10 and b with 20, and the function is called by passing a and b. It is taking x as a and y as b. So it means this will be directly accessing this a as x and this y as b. Already you know about call by reference. In call by reference, those are nothing but alias or another name for this variable, nickname for this variable, just another name. X means this a only. So inside the memory, if you see, this is 10 and this is 20, and that x is nothing but this a only, and this y is nothing but that b only. So that function can directly access these members. And also explain you, it's not possible for one function to access the variables of another function unless it becomes an inline function. So you know well that that function code will be copied at the place of function call. Yes, we know that whenever call by reference is used. Yes, we are aware of this. What is the benefit of call by reference? Benefit of call by reference is that, first of all, the code is simple for a programmer. As a student, code is simple. Second thing is that that function is a very small function performing a very simple task, so it can be made as inline. So let it expand in the place where the function is called, and the formal parameters will not consume any memory. Yes, that's the benefit of call by reference. Alright, so you wanted call by reference, but in call by reference, function can modify the parameters, which will actually modify actual parameters. So if you see what is the output here, x plus plus, this will become 11. And print this one. So what will be printed? 11 and 20 will be printed. And this has become 11, right? It will print 11 and 20. Now, I want call by reference. Means the function should be taken as inline. It should be copied here. But it should not modify this. So just make it as const int. That's all. So it cannot modify this variable now. So parameters can also be made as constant. So that's all. These are the usages of constants.